All right, let's jump right in. Welcome to this explainer. Today, we're taking a highly structured, incredibly detailed tour of the Bombardier Q400. We are going to strictly follow the airplane operating manual, step by step. We're talking the whole shebang, starting from the exterior lighting on the tarmac, all the way up to the automated ground proximity warnings in the air. To keep you anchored as we move through this, here is your first memory aid. Inside and out, ground to sky. That's going to be our logical progression today. We start on the ground, and we end high up with the airborne systems.
Here is our exact flight plan for today. 1. Aircraft lighting systems. 2. Emergency lighting setup. 3. Cockpit navigation displays. 4. Audio and radio controls. 5. Traffic avoidance. And 6. Ground proximity warnings. The best memory trick to keep this straight is the acronym LENATG. That's Lights, Emergency, Nav, Audio, TCAS, GPWS. That is the precise sequence of our manual review today. Let's get to it. Section 1. Aircraft lighting systems illuminating the Q400. We're kicking off our tour on the outside of the aircraft. We have to check the systems that guarantee absolute visibility and safety, both on the runway and up in the air. The absolute crucial point here, and your memory aid for this section, is simply see and be seen. That is the dual, non-negotiable purpose of all exterior aircraft lighting. So let's break down exactly where these lights are located, right? We start right near the center with the approach and flare lights, which sit just outboard the nacelles. Next, the taxi light is positioned squarely on the steerable nose gear. Moving outwards from there, you'll find your green and red position lights right on the wingtips. Then, the flashing white anti-collision lights are located on the tail bullet fairing and the lower fuselage. And finally, the inspection lights shine directly onto the engines. To lock this visual in, just remember the sequence: nacelle, nose, wings, tail, engine. You're literally just following the light path starting from the center of the aircraft and moving outward. Section 2. Emergency lighting setup, cabin safety. Okay, stepping inside the cabin now. The Q400 is heavily equipped for safety here. We've got ceiling lights, highly reflective floor markings, locator signs, and an egress light specifically for each passenger exit. Now, what's really important is that every single one of these is powered independently by emergency battery packs. A quick memory hook for this setup is CFLE. Ceiling, floor, locator, egress. Now, while we're inside, there's actually a really fascinating requirement for the next-gen Q400 interiors. For those photoluminescent floor path strips to actually work properly, the manual strictly mandates that the cabin ceiling and sidewall lights must remain on full bright for a minimum of 15 minutes. Why? Well, it's to recharge those floor paths before the first flight of the day, or, honestly, any time the aircraft has sat in darkness for more than 3 hours. Your mental shortcut here is 15 to glow. 15 minutes of bright light charges those floor paths right up.
And a quick note on layouts. If you are operating the unique Bombardier Q400 passenger and cargo combi configuration, the fuselage is literally split into distinct cargo and seating zones. In this specific setup, the maximum passenger occupancy is strictly capped at exactly 50 passengers. And that rigid limitation directly dictates the layout of the emergency exit passageways we were just talking about. The memory aid is super straightforward. Combi, 50. Half cargo, maximum 50 people.
Section 3. Cockpit navigation displays. The flight deck. All right, jumping into the pilot seat. Up here, we rely on these screens for absolutely everything. The primary flight display, or PFD, shows you all the essential immediate flight metrics. Meanwhile, the multifunction display, the MFD, can be toggled between ARC and full modes to show you map and weather data. To keep their roles straight in your head, just think PFD, primary, MFD, multi. The PFD is for flying the actual plane. The MFD is for mapping the world around it.
But you might be wondering, what's actually feeding the data to those screens? Well, your primary flight display is powered by the AHRS, the Attitude and Heading Reference System. It gives you your crucial pitch, roll, and heading data. According to the manual, this system needs exactly 60 seconds to mathematically align while you're stationary on the ground. Or, if you're doing it in the air, it takes 90 seconds during unaccelerated straight and level flight. Your memory link here is simple. AHRS aligns attitude. It's the mathematical brain keeping the plane's posture totally correct.
Section 4. Audio and radio controls. Communication hub. Look, before taking to the skies, we absolutely must set our communications using the audio and radio systems. These govern all VHF comms and navigation frequency tuning for the entire flight. Remember this simple phrase: center for comms. The center console is where all the chatter is controlled.
Let's look closer at that center console. The Q400's RCDU liquid crystal display is how the cruise seamlessly tunes those nav and comm radios. It's color-coded. Active frequencies are displayed in bright green, while your preset or scratchpad frequencies are shown in cyan. But listen, here's the catch, straight from the manual. If you leave a cyan preset frequency untouched for 5 seconds without activating it, it just reverts. It's gone. To memorize this interface, think green is go, cyan is standby. Exact color codes for exact radio tuning.
Section 5, Traffic Avoidance or TCAS, Airborne Defense. Okay, we are airborne now. The Q400 relies heavily on the Traffic Alert and Collision Avoidance System, TCAS. It actively interrogates other transponder-equipped aircraft in your vicinity to provide real-time threat advisories. Your mental link is TCAS tracks traffic. It's essentially an automated radar looking out for nearby planes.
When you're up there, TCAS categorizes threats in 2 distinct ways. A traffic advisory, or TA, which shows up as a yellow circle, is simply a visual and oral warning telling you, hey, an aircraft is nearby. But a resolution advisory, or RA, which is a solid red square, well, that escalates things. An RA generates actual immediate pitch commands for the pilot to avoid a mid-air collision. So remember, TA tells, RA resolves. Advisories just warn you, but resolutions demand immediate action.
Now, when you're tracking that traffic, altitude context is everything. Intruder altitude can be displayed in absolute mode, which is the target's actual mean sea level altitude, or relative mode, which is the target's altitude directly compared to our Q400. Interestingly enough, if you manually select absolute mode, the system will automatically revert back to relative after a set time. To remember this, think relative relates to you. ABS is their true height in the sky. REL is the height difference between you and them. So we've got the sky mapped out and we're avoiding traffic. But what about the ground? As we shift our focus from airborne threats to ground threats, we need to understand exactly how this aircraft anticipates and prevents controlled flight into terrain. Your memory trick as we make this pivot is look down to lock in.
Section 6, Ground Proximity Warnings, Terrain Defense. The Ground Proximity Warning System continuously monitors the aircraft's flight path anytime you are between 50 and 2,450 feet above ground level. It triggers visual and aural alerts to prevent you from hitting the dirt. Think GPWS guards the ground. It's the system specifically designed to warn you long before an impact becomes inevitable. GPWS breaks ground threats down into 4 very specific, dangerous flight profiles. Mode 1 triggers if you are dropping too fast. Mode 2 triggers if the terrain is rising rapidly toward you. Mode 3 activates if you start sinking right after takeoff. And Mode 4 triggers if you are flying too low without the proper gear or flap configurations. The absolute easiest way to memorize the 4 fatal flaws that GPWS monitors is the phrase drop, rise, sink, low. Let's actually dive a bit deeper into Mode 4A, specifically when the landing gear is up. Imagine you're on an initial approach. If you are under 48 knots and you drop below 500 feet, the system fires off the alert too low gear. However, if your airspeed increases to over 200 knots and you are below 750 feet, the threat priority shifts entirely. The system escalates the warning to too low terrain until you gain altitude. To remember how the system prioritizes these warnings based on your speed, just think slow means gear, fast means terrain. As we wrap up this explainer, I want to leave you with a question to chew on. We've just walked through the incredible engineering of the lights, the navigation, the ACDU, TCAS, and the GPWS. But with all these automated defenses in place, what is the ultimate deciding factor? The manual makes it perfectly clear. The final layer of safety is always the pilot's precise understanding and execution of these manual limits. Systems like the Q400s are incredibly advanced, but ultimately, system support, pilots perform. That is your final takeaway from mastering Q400 operations. The plane tells you what you need to know, but the human in the seat still has to fly it. I hope this structured journey through the Q400 manual has brought these systems to life for you. Keep learning, keep studying, and I'll catch you in the next explainer.